got some simultaneous equations to solve for this one. It doesn't say which method to use, but looking at those, substitution is pretty much definitely going to be the best one to use. Obviously, the second one is the really awkward looking one. I don't think trying to make X or Y the subject of that one is going to get me very far. So if I look back to this first one, the question is it easier to make X or Y the subject? Don't really think it makes much difference. Looking at the second one, is it going to be easier to substitute in X or Y? I actually think it's going to be easier if we substitute in for Y, because Y only appears once. So that's going to make me go back to this one and add the X and subtract the 7, so that then I've got an equation in Y that I can substitute into this second equation. Okay, it would work the other way around. I just think this is probably going to be the slightly easier way to do it. So all I'm going to do is on this equation where it says Y, I'm going to substitute in X minus 7. So 3x squared minus 2x, and then where it says Y, I'll substitute in X minus 7. Okay, and then, so it's a quadratic, so I need to simplify it all down and then make it equal 0. Okay, so I've got 3x squared minus 2x squared. I've got 14x minus 4x. I think this one factorizes, yep, so x plus 6, x plus 4. So my solutions are minus 6 and minus 4, but don't forget it was simultaneous equations, so we need to go back and find our y values, and the easiest way to do that is definitely going to be to use that equation there. So I just do that working over here. So y is x minus 7, so if x is minus 6, y is, minus 6 minus 7, so minus 13, and if x is minus 4, y is minus 4 minus 7, so minus 11. And then I would always just give those as a pair of coordinates at the end. So minus 6 minus 13 is one solution, and minus 4 minus 11 is our second solution.